In this video, I will show you what a holdup time is and how you can calculate the capacitance that you want in order to get a specific holdup time. So in this case, I will just use a PFC to show you what happens. So when there is a power outage, the voltage supply will be zero. That means that the input voltage going into the boost converter, in this case, is also zero, and the current going through the inductor is zero, and also the current going to the output from the PFC. But we still want to be able to provide the power going out. And all of that power will now be coming from the capacitor. But as you know, the energy in a capacitor is not infinite. So the voltage would start to drop. So let's say that the PFC operates at 400 volts normally. And we don't want it to be below 350. So the holdup time is the time it takes to go from 400 to 350 after a power outage. So it will be this time here. And this could, for example, be 10 milliseconds. We could, for example, want a capacitor that will provide at least 10 milliseconds of holdup time. So in order to find the capacitance, we want to look at the energy in the capacitor. So I will just use this part of the circuit because the PFC that is here doesn't really do anything after the power outage. So before the power outage, the energy in the capacitor is ECN, the nominal energy. So this is basically the same graph as the last graph, but now we just have the energy instead. After the power outage, the energy in the capacitor will start to drop. And that is because we're actually delivering power to the output. So the difference in the energy at the start and the minimum voltage is the energy that is going to the output. And this could be calculated as the P out multiplied by the holdup time. So you can maybe see that now we can write an equation where ECN is equal to the minimum energy plus the energy going to the output. And the energy in the capacitor could be written as 1/2 multiplied by the capacitance and multiplied by the voltage squared. So if we just put this here into this equation with also this one, we could solve this and find the capacitance. So we would have 1/2 and then C v squared n and then minus, because I just moved this one over, vc min squared, and this is equal to the output power multiplied by the time, the holdup time. So if we now just solve for the capacitance, we will get 2 multiplied by the output power multiplied by the holdup time, and then over the nominal voltage square plus minus the minimum capacitance voltage squared. So this will be the equation that you use to find the capacitance. So you can see from this equation that in order to get a higher holdup time, you need to increase the capacitance, which makes sense, right? So if you want a very big holdup time, you need a big capacitance. But the size of that capacitor would be really big, so it's not that power dense. But another way to increase the holdup time is to have a baby boost after the PFC. And I will explain how you do that in my next video. And this solution will increase the power density because the baby boost is a lot smaller.